Today we are going to discuss about data types in HANA. Okay, so when coming to data types in HANA, these are the different data types that we use in HANA database. Okay, so today we are going to discuss on some few of the most used data types. Okay, I'm not going to discuss on these large object types and special types and remaining data types. Let's see one by one. Okay, so first one is char type. Okay, in HANA we have to, we have char type data types, which is nothing but here character string types. Okay, so SAP given almost 4 different type of character string types: varchar, nvarchar, alphanumeric, and short text. Okay, now let's discuss each one of type, what it is exactly. So what is varchar? The varchar n data type specifies the variable length character string where n indicates the maximum length in bytes and is an integer between 1 to 5000. So what it means is so first of all, where we use the data types, that is important, right? So where we need to have a requirement to define the data types. When you are defining a table in SAP HANA, there you need to specify each column and its corresponding data type. Okay, so if I go to my system, when you are creating a table, for example, in the table we will give then fields information, means nothing but column information. So when you define a column, for example, given one test column, after giving column name, it is required to provide the which data type this column belongs to. You see, these are all the different data types what SAP already given to us. So whatever currently we are discussing, those are nothing but these data types only. Okay, so if you see my document number, I define this column as a varchar data type of length 10, and when it comes to customer name, I given nvarchar. But you see, when I given nvarchar, by default system defines one as a length. Then you need to change it to your according to your requirement. Okay, so when, for example, customer name is there, so I want to allow my customer name till 100 characters, then you have to specify that 100 here. If you forgot to specify, then system will consider by default it as a 1 only. Okay, so this is the place where we have a need to assign the data type for each column. And where else? So here I am creating a table in a graphical way, so SAP giving this functionality to choose the data type of the available ones. But for example, if you are creating your own, table via SQL. So in HANA Studio, we can open SQL prompt by selecting your schema, and then go to the SQL prompt. Okay, here you can write your syntax to create a table. Okay, so when you write your own syntax like your own SQL statement to create your table, there you need to type what type of data type it is. I will show you the one example for that also. Okay, so this is place we will use the data types. And when you are creating any calculation view, and in the calculation view, if you are creating any calculated column, then there also we have a requirement to specify what column, what data type that particular column represents, calculated column. Okay, so these are the main places where we use our even table functions procedures also we use it to define variables under using these data types. Okay, this is the place exactly where we come across the usage of these data types. So in order to use it, first of all we need to know what is each data type and what is the and then based upon our requirement we will provide the corresponding data type. So now here in this particular screen we are going to discuss about two data types, varchar and nvarchar. So what is the major difference between varchar to nvarchar? So here, as per the description here, varchar represents character string. Okay, and as per the description here, nvarchar represents Unicode character set string. Okay, so there is a difference between varchar and nvarchar. Its length and everything is same, but the type of data it stores differs. Varchar supports only string types and nvarchar supports Unicode character string set. So for example, German letters, Chinese letters and all those are right. Those kind of characters varchar doesn't support. Okay. For example, any alphanumeric string Varchar supports, but Nvarchar supports even special symbols also. Okay, Unicode character set like Chinese symbols and all. Okay, so whenever you have a requirement to store information, for example, customer name. So sometimes customer, if it is in China, then when you are typing your customer name, maybe it is in a when the language based upon the language, na. So they, in such cases, to store the customer name, we will give Nvarchar type. For example, comes to document number. I given one example also here. So here when you're creating a document number, you know in our SAP mostly document number is a char type of length 10. So in these cases, simply you can define this kind of columns as varchar. If you are creating a custom material name, so then also you can go for varchar. But whenever you have a requirement that the column may contain some special characters and all, then in such scenario, better to go for nvarchar. And what was the syntax of defining it? The syntax for defining this varchar is, so in the table you need to give the varchar, and then in the dimension column you need to specify the length of it, how many characters it can support. So you can give max till, so as per this you can give max till 5000, between 1 to 5000. Okay, so going to next. So here I try to differentiate between varchar and nvarchar. So varchar is a variable length which supports only non-Unicode characters or character strings. Okay, and nvarchar supports Unicode and non-Unicode both. It will support both, like a hybrid kind of varchar, and is nvarchar. And the maximum length of varchar is 8000 characters and nvarchar is 4000 characters. Why? Even though the both size here, if you see here, both allows only 5000 characters, but here when comes to maximum length 8000 and 4000. So why this difference came means in the character size. When this data storing into the database, varchar takes 1 byte per one character, but nvarchar takes 2 bytes per one character. That's the reason. So number of characters is decreased when compared to varchar and nvarchar. That's why when you are trying to store information, when you're trying to create any table, choose between varchar and nvarchar wisely as per your requirement. That's it. So nothing to discuss much about this one. So and coming to the next, alphanumeric. The alphanumeric data type specifies a variable length character string. So this is also a variable length character string only that contains alphanumeric characters where n indicates the maximum length and between 1 to 127. Okay, so this is also alphanumeric like nvarchar only, varchar and nvarchar. But if the requirement of number of storing characters is, when you see it doesn't, your particular field doesn't require too much space, then go for this alphanumeric. Sorting among values of alphanumeric is performed in alpha representation. But mostly, like whenever we create tables, we mostly go for varchar, between varchar and nvarchar. Whenever you have any special requirements, then we can go for alphanumeric. And short text also same kind. This is also same short text you can define, and n defines the maximum length of it. Okay, and the data type can be defined for column tables but not for row tables. So when you are using short text data type, make sure your table must be of column table, not a row based table. Okay, that's it. I don't want to discuss much about this alphanumeric and short text because in real time we mostly go between varchar and nvarchar. Based upon our requirement, we come for alphanumeric and short text. Okay, whenever what supports variable length supports, if you are using short text, means if you have a requirement for your column that supports searching features and all, then you go for short text. Okay, so coming to the example, like I already shown in the database also, in the system also, like when creating a table, we need to specify the columns. In the columns, we need to, for each column, we need to specify the corresponding SQL data type. And after that, we need to specify the length of it. If you don't specify anything, then it will consider it as a 1. Okay, and here I given screenshot which shows all the different data types that we have in our SAP HANA database. Okay, so here, so this is the earlier screen. Here I am representing how exactly it shows on a graphical way of creating table. In this screen, here I am telling like how we can create a table via SQL statement. But when you creating a table via SQL statement, you see here you need to type the data type. So if you want to define in this way, first of all you need to know what are the different data types, and how we define it. Varchar and char, varchar of 10. So this is the representation of to define a varchar variable of length 10. If you want to define a nvarchar variable of length 10, simply type nvarchar. So column name space data type within the brackets length of its value. Okay. So here my document number I am expecting maximum 10 character size. That's why I given 10 in the brackets. Okay. And regarding this create table statement, we will learn in the coming sessions. Okay. Not in this one. Here the main focus is on what are the different data types we have in HANA database. So next, jumping into the numeric data types. So we have, these are the different numeric data types. We have tiny int, small int, integer, big int. So one second, if I go to the initial screen, here we can see clearly numeric data types, not only these: tiny int, small int, integer, big int, decimal, small decimal, decimal, real, double. So these are all comes under numeric data types. Okay. So coming back to this slide, here we will see each one, what is the use of it. So tiny int. So when we define a column as a tiny int. So when we have a requirement to store a value of maximum, value between 0 to 255, then you go for tiny int. Okay. So why? So generally you can define it as an integer also. Okay. But first of all, let's go for small int and integer. Then I will tell you one more point. So small int, when we use small int data type, if we have a requirement to store value between 32,768 minus 32 and between 32,767, then we go for small int. Okay. And when you have a requirement to store very big value on your, integer, tiny int, small int, integer, these three are purely numbers, not decimal numbers. Okay. If you have a requirement to store a rounded figures, then you can go for tiny int, small int and integer. And between these three, why everyone generally uses integer. But what happens if you are using a column as an integer without knowing how much value it may max store? What is happening is unnecessarily you are wasting your database size. Because when you define a table and when you store one individual row, each row occupies some data in some space in your database. Unnecessarily for serial number column also, if you are using it as an integer, which may not cross more than 255 column, in that case you are unnecessarily wasting some database space. Okay. When comes to HANA database, it is too costly. So wisely we need to define tables according to the requirement of the each field. Okay. Saving database is a primary concern here. Okay. So tiny int, small int, integer, both three are same category to store a rounded value, but based upon the number range we want to store in that particular column, we go between any one of these three. Okay. So going to the big int. So big int is also a number which stores a very huge number. You see this is the number I cannot read, but if you have a requirement to store your value in your column between this number range, then you can go for big int. So this is all about integer data type here: tiny int, small int, integer, big int. So going to next. So decimal. Here we are going to talk about decimal data type. So a decimal data type, how we define decimal. So first of all, before going to this one, I am going to define, show you on the screen. Here you see quantity. Here quantity is of type decimal, and in the length column, I given two fields, 17, 3. So here 17 is nothing but my precision. You see precision, and 3 is nothing but number of decimals I am expecting in this quantity. Okay. So decimal is a SQL standard notation for fixed point decimal number. Okay. And here when you define a data type as a decimal, you need to specify two numbers. One is the precision number, another one is the scale number. If you don't mention anything on scale, then system will consider it as a 0. Okay. The same point I written at the end. Precision can range between 1 to 38 and the scale can range from 0 to p. If the scale is not specified, then default is 0, then 0 decimals. Okay, so next important point here is, so one example of defining decimal is decimal. Within the brackets we will mention 5 comma 4. Okay, here what 5 means and what 4 means. Okay, 5 means precision, 4 means scaling, means 4 decimals I want in my number. Okay, and one next point is p is precision or the number of total digits. Okay, so if you are defining a decimal with 5 comma 4, it means the total, okay, total length of your uh, number, means including decimals, including before, dot before and after. Total number of numbers in your number must be max of this one. So that's what here it is saying, the number of total, the sum of whole digits and the fractional digits. So p always represents number of sum of the whole digits and the fraction digits. So if you see here 3.14, for example, I define a column with decimal 5 comma 4. Then if I define it, if I am trying to store a value of 3.14, then system stores this value as 3.1400. It means if you count total number of digits in this particular number, it is 5, which is nothing but my precision. And if you see the total number of digits after the decimal, it is 4, which is I defined on the scale place. Okay, if you take 3.1415, then 3 is total number of digits is 5 here, and it will take exactly the 4 decimal numbers. If you try to store more decimal numbers into your column, which is defined as 5 comma 4, what system will do is it will take only 4, max 4, because you defined the scale as 4, it will take max 4 only, and after that 1 2 3 4 9 2, it will exclude these two values. Okay, it will exclude these two values, only takes 4. And always remember, if for example in this screenshot I given decimal 17 comma 3, it means my total number of digits I can store in this quantity is max 17. Out of it, 3 places it will take for decimal, and remaining 14, 15 16 17 14, remaining 14 I can give the whole number. Okay, very important. It is the same in ABAP also. So when you want to define a bigger number, your precision should be bigger here, and this particular precision maximum can take between 1 to 38, not more than 30. So this is all about decimal data type. Okay, next coming to numeric data type. Under the numeric data type, next we are going to discuss about floating point. Okay, so decimal data type contains precision and scaling. Okay, but when it comes to floating, we have only one, which is precision. Okay, a float data type is a 32-bit or 64-bit. So when you are defining any column with data type float, then it can be stored in the database either with 32-bit or 64-bit. Okay, here n specifies the number of significant bits and can range between 1 to 53. So if you are defining a float, you can give max till 53 only, between 1 to 53, not more than that. And the next point is, if the value what you are giving next to float, if it is less than 25, system stores this column as a real data type. Okay, so real is another data type. Okay, means if you see here, float is the main parent one. If you give the length less than 25, then this particular column system will consider it as a real data type, and if it is greater than or equal to 25, system consider this float as a double. So these two are nothing but which is merged under float only. Okay, so what is real? Real data type specifies a single precision of 32-bit floating point number. Okay, so 32-bit floating point number, we consider it as a real number. And what is double one more thing what I said here, double. Whenever this length is if whatever float you defined, If the number between length is more than greater than or equal to 25, then it consider it as a double, which is nothing but 64-bit floating point number, and which can store data a minimum value of this much to this much. Okay, yeah, it's a very big number. It's very difficult to tell also. So we discussed about float and real and double. Now the next one is small decimal. So small decimal and decimal. Earlier we discussed about decimal. When we discussed about decimal, I said the precision can range from 1 to 38, correct? When comes to small decimal, the precision can range between 1 to 16. So if you feel like your precision will not go max 16 characters, means total number of digits in your number must is not going beyond 16 characters, then you can go for small decimal based upon it. Generally in real time we will use decimal, we don't go for small decimal. So that is all about numeric data types. Okay, so if you want to see it in the system, there is nothing much to explain here. So when we create the table, as per our requirement, we will specify whatever data type it is: small decimal, float, real, and all. And one important point here is, you see, when I am giving decimal, I am giving 7,3. It means this total number of digits in my quantity decimal can store up to 7 with 3 decimal places. And for floating, you see, for floating, I don't have, I can give 4 length. 4 length. And when I am defining real, when I am defining it as a real, you see, there is no, I don't have option to give the length here at all. Okay, when you define a real, you don't have option to define number. And for example, when I go to double, here also system is not asking to provide any number. Only for decimal numbers you can give how many precision in decimal, and floating point also system will ask you what is the length of the floating point number. But for real and double, system doesn't, you no need to specify any length. Okay, that's what we need to understand here. So next, so going to the next data type. So yeah, this is how it is. 1 second. Going to date time data types. So what are the different date time data types we have? So we have date, time, second date, and timestamp. These are the 4 different data types we have under date and time data types. Okay, now let's see one by one clearly. So what is date? A date data type consists of year, month, and day information. Okay, and what was the default format of date in our HANA? The default format of date in our HANA is YYYY hyphen MM hyphen DD. So this is the default date format in HANA. So when you are loading data into HANA Studio, you should maintain date format properly. Okay, in SAP the default standard date format is YYYY MMDD, but in HANA it stores internally whatever date you storing in the date type of column, it stores internally in this format. For example, from the date, if you want to extract the month information, so you must extract information from 1 2 3 4 5 from 6 to 7. So 6 and 7 characters are your month information. Whereas if you go to SAP ABAP and all, so generally 5 and 6 are the month characters. But when it comes to SAP HANA, if you want to extract month or date from your date information, then you must remember that there is a hyphen in between year and month. So you should consider this also one character and extract from 6th character to 2 places. Okay, so that's why it is important to remember what type of format SAP stores in HANA date in HANA system. So the range of the date value between this to this. Okay, this is fine. We won't give more than that. And coming to the time. So a time data type consists of 4 hours, minutes and second information, and this is the standard format of time, 24 hours format with MI and SS. So yeah, here no need to, whenever we are trying to save time value now, we must provide in this format. Coming to the second date. Second date data type consists of year, month, date, hour, minute and second information. You see, year means date plus time. Date plus time is nothing but second date. Okay. So this is the minimum and maximum date what you can store under the second date. When coming to timestamp, so what is the difference between second date and timestamp? In timestamp also I have year, month, date and hours, minutes and seconds. Along with it, we have fraction of seconds also available in the timestamp. But in second date, we have only the date and time information. So if you have something you want to store only date and time with respect to seconds till seconds, then go for second date. And if you want to store fraction of seconds also, then go for timestamp. Here FF7 is there, right? 7 actually is a number field. You can change this one. Okay. FFN. This is the representation of fraction of seconds. This represents where n indicates the number of digits in the fraction part. How many fraction of digits you want to capture. Na? So such, that much number you can give it here. Okay. So that's all about date and data types. Now we are going to Boolean data type. Okay. What is Boolean data type? The Boolean data type stores the Boolean values which are true, false and unknown, where unknown is nothing but null. Okay. What is Boolean data type? Boolean data type is nothing but true, false and null character. Okay. When the client does not support Boolean type, it returns 1 for true and 0 for false. So here I provided one example to understand what is this Boolean data type. So I created one table where I created one extra column called bool underscore flag, and I defined this bool underscore flag as Boolean. Okay, you see, this is how to define a Boolean data type. If it is a graphical way, simply selecting Boolean will enough. But if you are defining it via SQL, then you need to define in this way: column name space Boolean. And if you want to insert data into this particular column, in what way you have to provide? You have to provide in this way. If you want to store true information, you need to type true. And if you want to, store false, then type false, and null means unknown. Okay. So these three you need to, you can nothing. If you don't store anything here, then nothing but null here. Okay. So this is how we store information into a Boolean flag kind of column. And when you retrieve this data from this column, how it looks like. That's why I given one select statement also on this table. You see, when I am retrieving data from this table, instead of true, it is showing it as 1. Why it is showing it as 1? So we written here, when the client does not support a Boolean type, it returns 1 for true, 0 for false. Since I stored my data as a true, it returns 1. If I stored false, then it will return my 0 here. Okay, so this is about Boolean data type. Now going to binary data type. Okay, so what is binary data type? A var binary data type is used to store binary data of a specified maximum length in bytes, where n indicates the maximum length and is an integer between 1 and 5000, between 1 and 5000. Okay, so yeah, to understand it more better way, I give an example also here. So I created a table, and in the table I created one variable called binary underscore string. So I given one spelling mistake t, but I created one column of type var binary. So how to define binary here? By using var binary, we can define a column of type of binary data type. Okay, and within the brackets we need to specify the maximum length. We can specify the length between 1 and 5000. Okay, and how to enter data into this var binary data type. If you want to insert data into a column of type var binary, so you can insert in this way. So here you see it is clearly mentioned here also. It was not mentioned here. Then okay, so when you're trying to insert a var binary information into your column, you have to specify x before the value. Okay, so 534150 is my binary information. Okay, and I want to store this information into my column. Before you are giving your string in the single quotes, prefix with the capital X. This is mandatory. If you don't give capital X, system doesn't consider it as a binary information. Okay. And if you and then what I did here, so I created a table. Here I shown how to create a column of type of binary, and then I shown you how to insert a record into this column, and next I am showing you how to bring data. So when you bring how to bring, simply by writing select statement on this table, you can see the stored information. You see 534150. This capital X doesn't store in our database. Okay, this capital X only represents that whatever data you are storing into this particular column is of kind binary. Okay, and we have you see the last point here is a value of type binary can be converted to a value of type Nvarchar if its size is smaller than or equal to 8192. What it means? So whatever here I try to show one example here. I written one select statement on the same table ZAN text. Here whatever binary information I stored, I am trying to convert it into string. So to do so, I can use this particular function bin to string. Bin means binary to string format and provide your binary information here. So what happened? You see 534150 is nothing but SAP. Okay, if we convert this binary into real-time character string, the character string here will come as SAP. Okay, so this is the example how to convert binary. So we clearly here I try to clearly show you how to create a column of type binary, and then how we can insert data into it, and how we can convert the binary information from binary to string format. I hope it helps. So going to the next. So multi-value data types. Okay. So what is multi-value data types? It is nothing but array. Okay. So in other languages also we have this kind of data type, array data type, where this is only one object but store multiple values. Okay. An array type is used to store collection of values sharing the same data type, where each element is associated with exactly one ordinal position. Okay, so nothing but stack, you said it. Array is kind of a stack. Okay, one data type which stores multiple collection of values. So how to say this one? Simply by giving let's see this example. We can easily understand it. Generally, array, we cannot define array in our regular tables. Okay, this array data type we use in table functions and procedures. Okay, but not in while creating tables. Mostly we use it in that's what I written here. This data type we use in table functions and procedures mostly. Okay, so how to define a variable of type array? So declare array names. This is the variable name which I am trying to give, and then Nvarchar 50 of 5. Okay, so means I am creating and after that I need to define array here. What happens is, generally without this array statement here, then this is simple one variable of type Nvarchar. But on the same variable, if you want to store multiple values, then you need to define it as array. So what it means, you see here I try to store multiple strings, Militia and Siri. These are two different names. I want to store two different names in one particular variable. Then I need to define that kind of variable as of type array. And how to bring single value, like single name, from my variable, because this variable is storing multiple strings. I want to get one string out of it. How to get it? By defining in this way: colon, array names, and the position. So Militia occupies the first position and Siri occupies the second position in my variable. So if you give this number in the square brackets, if we give 1, Militia will be the output, and if you give 2, then it will bring data from the second column. Like this you can define arrays. So we can see this example again one more time when we discussing about table functions and procedures. Okay, na? So yeah, that's all about data types. So we tried to cover most of the data types that we are currently using in HANA database, and I hope it helps. Okay, na? Thank you. Stopping recording.